Hi, I'm Ling. Currently, I'm a postdoc researcher at Professor Raphael Zach's Virtual Construction Lab at the Technion, Israel Institute of Technology. I'd like to show you a system that I developed. It's called SeeBIM. SeeBIM stands for Semantic Enrichment Engine for BIM. The development of this system is supported in part by the EU Infrared-funded research project called SeeBridge. The system utilizes Trimble Connect's API, especially the 3D viewer, for interaction with the BIM model. You can log in the system using a Google account. Create a project. Open the project folder. Add a model to the project by uploading an IFC file from your Dropbox account. Once the uploading process is complete, you can open the model in a 3D viewer. You can select an object in the model. The system will show you the attributes and the properties of this object defined in the IFC file. You can easily add your own property sets and properties. So that when others check this model, they can see this additional information. The system can extract a list of geometric features of an object. You can query objects based on the pairwise relationship in the spatial context of the model. For example, get all the other objects that are connected to this selected one. Then find other parallel objects in this set. Or you can first find other objects that have a lower centroid. Then find objects that are shorter. Finally, select objects that are smaller. The objects may be modeled using incorrect object types, but the system can run an automatic object classification process. The system derives all the geometric features of every object. It also derives all the pairwise relationship between every object. We have bridge engineers predefine a knowledge base that lists geometric features and the pairwise relationship of typical bridge elements. By matching the objects in the model with the bridge elements in the knowledge base, the system can infer the object types of every object in the model. Now when we check the model, the object's classification results have been added to the user property sets. Originally, we used column to represent the shell key, because in the BIM software there's no shell key in the model library. But based on the pairwise relationship, the system was able to identify that this object is more likely to be a shell key than a column. Although the geometric features show that it could be either a column or a shell key. Another example is about bearings. Originally, we used a column to represent a bearing. Again, the system was able to identify that it's more likely to be a bearing than a column. Information is the core of BIM. However, the information quality of a BIM model is usually very poor, especially when we are facing the information interoperability challenge. The objective of SeeBIM is to help the user easily enrich a BIM model. You can add information manually. The system can automatically classify the objects that might not be represented correctly in the original model. Thanks for watching. I'm Dr. Ling from VCLab.